Example 6. Here we have a rational expression, and we have the denominator factors x and the quadratic factor x squared plus 6x plus 13. So the first thing we want to do is we want to first of all write it in its partial fraction form. So notice that the numerator is 1 degree less than the denominator, so we have a over x. And then over the factor x squared plus 6x plus 13, we write it as bx plus c. So what we're going to do is we're going to look at that denominator, that quadratic denominator, and check for factors. So in this case here, it's not factorable. So if it's not factorable, then we have to think that this could be an arctan type, or type 3. And so we should check the discriminant here and check to see if the discriminant is less than 0. So b squared minus 4ac, so we're going to check that b squared minus 4ac, which is going to be 36 minus 4 times 1 times 13. And we're going to check this value. We end up with negative 16, so 36 minus 52 is negative 16. The fact that it's negative means that it's less than 0. So we know that b squared minus 4ac is less than 0. There are no real roots. So what that indicates then is this is going to be type 3 or the arctan type. So we're also going to then set up a system of equations to solve for a, b, c, and then we can set up this for the arctan type for the blue portion of this. So setting up a system of equations, we're going to end up with a times x squared plus 6x plus 13 plus, we're going to have x times bx, so I'll write this as bx plus c times the factor x. Okay, and we know that this is going to be equal to what we had to start with, which is 5x squared plus 11x plus 26. Okay, so we're going to end up with, in this case here, we can set this up. I'm going to solve these coefficients by, first of all, letting x equal to 0. So I'm going to let x equal to 0. And then what ends up happening is this portion here becomes equal to 0, and I can solve this by plugging in x's in here. So I get a 0 squared plus 6x plus 13, so I have my 13 left over here, plus this term simplifies to 0, and on the other side here, when I plug x as 0 in, I get 0 plus, so 5 times 0 plus 11 times 0 plus 26, so I get that equal to 26. So solving this equation, I get 13a equals 26, or a equals to 2. Okay, I'm just going to put a square around that to make sure that I kept track of that. So that allows me to kind of get an a coefficient right away. It makes it a little bit easier to solve the rest of this. So then I'm going to expand this out. So expanding this out, I end up with, so this is part 1. Part 2 is the solving for b and c, so I'm going to expand it out. So I get ax squared plus 6ax. In fact, since I know what a is, I'm going to replace that afterwards, actually. So write that out first. 6ax plus 13a plus bx squared plus cx, and that's going to be equal to 5x squared plus 11x plus 26. So the first part here, solving for a, I just made one of the factors equal to 0. For solving for b and c, what I'm going to do is equate coefficients. And since I already have a solved for, I'm just going to replace that. And I end up with 2x squared. So I end up with 2x squared plus 6 times 2 is going to be 12, so I get 12x plus 13 times 2 is going to give me 26, and then plus bx squared plus cx, and that's going to be equal to the expanded form here, 5x squared plus 11x plus 26. Okay, so that I can start equating coefficients. So I'm going to group these coefficients. So I end up with 2 plus b. That's going to be the coefficient on my x squared. When I group my x terms, I get 12 plus c x plus 26 is equal to 5x squared plus 11x plus 26. Okay, so I can match my coefficients, so I know my 26 is already matched. I can match my x coefficient 11 with the 12 plus c, and then I could match my a coefficient, my 5, with 2 plus b. Okay, so I can solve these parts. So solving for b first, I know that 2 plus b is equal to 5. That makes b equal to 3. I can set up an equation for c. So 12 plus c is going to be equal to 11. So c works out to be -1. So I've solved for a, b, c, and then I can set up my partial fraction. Okay, so setting up my partial fraction now, which I can then integrate, I end up with a. So it becomes a over a, sorry, my a I solved for was 2. So a is equal to 2 over x plus, with the b, I'm going to end up with this integral here. I'm going to end up with b is 3, x plus c is -1, and that's all over that non-factorable, non-real root quadratic equation. Okay, so at this point, the red portion of this can be solved. Okay, we can work out that integral. So that integral is going to be 2 log x plus, in this case here, what we want to do is we want to do the substitution part of it, because this is going to split up into 2 parts. It's going to split up into a substitution part and an arctan part. So I'm going to give myself a little bit of space here. So we need to start with the substitution part. Okay, so I'm going to do this in green. So this is going to split up into its substitution, and then another portion of this will split up into its arctan. So we have to do the substitution part of this first. So the substitution, we're going to let u equal the denominator, x squared plus 6x plus 13. And then we're going to work out my du. du is equal to 2x plus 6. Now, we needed to match the 3x, and then we can account for the extra constant term separately, and that term is going to end up in the arctan portion. So if I multiply this by, so I'm going to take this and multiply it by 3 over 2, that's going to give me 3 over 2 du, and that's going to give me the 3x that I need, and then when I multiply 6 times 3 over 2, I get plus 9. So that's the the substitution portion that I'm going to need. Okay, so this is where I'm going to then split this up, and my substitution integral is going to look like this: 3x plus 9 over x squared plus 6x plus 13. Okay, so that's a 6 there. And then I'm going to have the leftover part then is going to be the arctan part of this. Okay, and how do I get the leftover part? Well, I know that the leftover part plus the arctan part, so the substitution part and the arctan part must get back to the original -1 constant term. So to work that out, to get that -1, I need 9 minus 10. So that then becomes the remaining part for the arctan. I need a constant in the arctan portion. So I'm going to highlight this. I'll do this and highlight this in red. So 9 minus 10 gets me back to the -1. So that's where that minus 10 comes from. We need that to make this equivalent. And so this is I've split up my fraction into 3x plus 9, which we'll able to apply substitution. And then we're going to end up with this minus 10 over x squared plus 6x plus 13. And this portion we're going to apply arctan to. So then the green, we need to generate the numerator by using our substitution for du, working that out, 3x plus 9, and then we're going to generate the arctan portion of it by figuring out what's left over with the constant. And this portion will be done with arctan. Okay, so then I've got all my integrals now set up. I'm going to do the green part with substitution. So here I'm going to end up with 2 log x plus, when I do my substitution, I'm going to end up with 1 over, the denominator is now u, I'm going to replace it with the u. The 3x plus 9, I'm going to replace with a du and a 3 over 2. So 3 over 2 du is going to replace that 3x plus 9 dx. Okay, so I'm just going to circle that. That portion there is going to be replaced by this expression here. Okay, so that's where my 3 over 2 du comes in, plus this portion here is going to be done with arctan. So for arctan, I need to have a perfect square in the denominator. So this is going to end up being x squared plus 6x plus 9, and then plus 4 dx, like this. Okay, so I can now keep integrating here. So 2 log x plus 3 over 2 log u plus, this is going to be, I'm going to put the -10, so maybe I'll make that -10, and this is going to be 1 over x plus 3 squared plus 2 squared. So then I can now apply my arctan formula to that portion. So this becomes 2 log x, so we worked out this part a long time ago, plus 3 over 2 log, and I'm going to replace the u with an x squared plus 6x plus 13. That's what I had defined my u as up in this portion here, minus 10. And now I can apply my arctan formula. So this is going to be 2 squared. So if it's easier to see, I'm going to convert this to 2 squared. Okay, so that makes that coefficient 2. So I'm going to divide by 2. I'm going to have my arctan, and it's going to be the input variable x plus 3 over the 2, and then we need to remember the plus c. Okay, and just so that you can see where these pieces are coming from, that 2 is going to be from here and here, and then the plus 3, if I could choose a different color here, that x plus 3 is the x in the formula. Okay, so there it is. My final answer then becomes 2 log x plus 3 over 2 log x squared plus 6x plus 13 minus 5 arctan of x plus 3 over 2. And don't forget the plus c.